Hi, my name is Brent Kim. I'm a faculty scientist at the Johns Hopkins Center for a Livable Future in the Department of Environmental Health and Engineering at the Bloomberg School of Public Health. A big focus of my research is looking at the implications of our rapidly changing climate on the food that we grow and what it means for our health. So our climate is rapidly changing. With those changes, we're seeing higher temperatures and we're seeing higher concentrations of carbon dioxide. And that's a greenhouse gas that is driving the climate crisis. Now, it's critical to ask, what do these changes in our climate and in our atmosphere mean for the food we eat? And what does it mean for our health? So we know, for example, from previous research that higher temperatures and higher concentrations of CO2 in the atmosphere can negatively impact the nutritional quality of the food we eat. So for rice, for example, we're seeing lower levels of important minerals like iron and zinc and lower levels of B vitamins with climate change. What we were interested in is an element called arsenic, which is linked to a lot of pretty bad health effects, such as cancer, and we can talk more about those later. But so rice is unique because of the way it's grown. It tends to take up arsenic into the grain of the rice plant. And this primarily happens in part because rice is flooded and arsenic is water soluble. And that flooded environment in the absence of oxygen creates the optimal conditions for arsenic to enter the grain of the rice plant. So our collaborators wanted to know, how is climate change impacting arsenic concentrations in rice? And what does that mean for the health of the billions of people who depend on rice as a staple crop? Our collaborators in China grew rice under 4 experimental groups. In the first group, they grew rice under ambient conditions, so just the atmosphere as it is now, or as it was when they did the study over multiple years. And in the second group, they grew rice under elevated temperatures. So they actually had heaters, infrared heaters around the rice to simulate a rise of 2 degrees Celsius in the temperature, which is exactly what we're seeing with climate change. In the third group, they increased the atmospheric concentrations of carbon dioxide by spraying CO2 around the rice paddies. And in the fourth group, they increased both temperature and carbon dioxide. Then they harvested the rice and they measured the concentrations of inorganic arsenic, that's the more toxic form of arsenic, in the rice grain. And what they found was that when you increase the temperature, concentrations of arsenic in rice go up. When you increase carbon dioxide concentrations, levels of arsenic in the rice go up. But what was really concerning was that when you have the combined effects of higher temperature and higher carbon dioxide, there's a synergistic effect that increases the levels of inorganic arsenic even more. So we modeled the additional number of cancer cases that we could expect to see under these different climate scenarios. And what we found, like looking specifically at the countries that eat the most rice in the world, such as China and Indonesia and India, right? And for a country like China, the additional number of cancer cases was in the tens of millions. So this is another reason why climate change is among the most urgent public health and ecological crises of our time and of future generations. So we need to be doing everything we can to slow the rate at which the climate is heating up. And at the same time, we need to take action to protect people from the downstream impacts of climate change because of the way it's grown, because the paddies are flooded. That creates ideal conditions for arsenic to enter into the rice grain. And there are microbes or bacteria in the soil that are involved in transporting arsenic into the rice tissues. And what's interesting is what we found was that the populations of those bacteria that are involved in bringing arsenic into the plant were much higher. So consuming rice is one of the main ways by which most people are exposed to arsenic. Drinking water is another big one, but rice is up there as well for all the reasons that we talked about. And in terms of how it impacts health, so arsenic exposure has been associated with lung and bladder cancer. Chronic exposure has been linked to heart disease, liver and kidney damage, as well as neurological and cognitive effects among children. I would just add that, I think some populations are more vulnerable to arsenic exposures than others. And in particular, infants and children may develop neurological or cognitive impairments from arsenic exposure. And they're more vulnerable because if you have an adult and you have an infant and they consume the same amount of arsenic, the infant has a much lower body weight. So the ratio of their arsenic exposure to their very small body is much higher than the ratio in an adult. So that's another reason why we need to be particularly careful about minimizing arsenic exposure among children. Yeah, so there's a lot of things we can do to reduce population exposures to arsenic through rice. So we can start on the production side. So we can look at farmers. So we can grow rice without flooding. So remember we talked about before how, it's the flooding is the main, it's really the flooding that creates the ideal conditions for arsenic uptake. So we can grow rice without flooding. That could greatly reduce arsenic uptake in rice. And there's a lot of research that's being done to find ways to do that effectively, right? So we typically flood rice paddies as a form of weed control because the rice plant is pretty hardy and it doesn't mind being flooded, but the weeds don't like it. But there are demonstrated ways to grow rice without the flooding. Second, farmers can test their soil and water for arsenic. That's critical to know what's in your water, what's in your irrigation water, what's in your soil. There may also be different cultivars of rice that are less prone to accumulating arsenic. And so choosing those cultivars over others could reduce arsenic accumulation in rice. And then we can move on to, food manufacturers, right? So sometimes you might find energy bars or maybe infant food that's sweetened with rice-based syrup. That's not ideal for arsenic exposure. We could instead swap out the rice-based ingredient with some other form of sweetener, or maybe no sweetener at all. On the policy side, we can make sure that there are monitoring systems in place to monitor arsenic levels in food and make sure that they stay below regulatory limits. We can also monitor arsenic exposure among the most vulnerable populations by analyzing their urine. But the white rice does have lower arsenic concentrations, so there's a trade-off there. In terms of how we cook and prepare rice, one thing consumers can do is they can soak their rice for 12 hours before cooking it, and then discard the soak water before cooking. Even better is to cook the rice in excess water. So you'd add a lot more water than you normally would to the rice pot, and then discard the excess water. Again, there's a trade-off here because you do lose some nutrients with that practice. But it does help remove a lot of the arsenic. Of course, it's important to make sure that the water is also not contaminated with arsenic. Finally, so my father was Korean, so rice is like a very important part of my cultural heritage. So I'm, not ready to give up rice, but, we could consider, maybe instead of eating rice at every meal, maybe we substitute other grains. So maybe one week, maybe for one Monday we have rice. And then on maybe Tuesday, we have something like quinoa. And then on Wednesday, we might have something with wheat. So kind of rotating in different rice, just so we're not eating rice every day. I would never tell people, stop eating rice, right? We just have to be smart about doing what we can to minimize our arsenic exposure.